Now let's have a look at question number 9. 9 part A. What are background radiations? Name one internal source and one external source of background radiations. So background radiations are radiations which are present in a locality in the absence of a visible source of radiation. So I'll repeat, background radiations are radiations present in a locality or in a vicinity in the absence of a visible source of radioactive radiations. The internal source of these radiations is presence of carbon 14 and potassium 40 present in our bodies. Whereas the external source is the cosmic radiations, that is the radiations coming from the outer space. The next question, part B of question number 9. Draw a neat label diagram of an AC generator. State the energy conversion that is taking place in the generator when it is working. So before I draw the diagram, I'll write the energy conversion. So energy conversion is mechanical to electrical. So basically a coil is rotated in the presence of a magnetic field and the rotation of the coil generates electricity, and therefore we can say mechanical energy is converted into electrical energy. Now I'll start the diagram with the field magnets, and these field magnets have concave cylindrical poles. There is a rectangular coil between the two poles, and this coil is wrapped around a soft iron core. So what I am shading right now is the soft iron core, and the coil is wrapped around it, and obviously there will be an axle about which this coil is going to rotate. Now both the ends of this coil has an attached slip ring, and when the coil is rotated about the armature, the slip rings rotate along with the coil. Now what I am drawing is a carbon brush. So both these rings are attached to a carbon brush, and carbon brush is generally made up of graphite, and it is a good lubricant and at the same time a good conductor of electricity. So slip ring S1 is connected to carbon brush B1 and slip ring S2 is connected to carbon brush B2. Now the brushes B1 and B2 are connected to each other with the help of a load resistor or via a load resistor. So what we have out here between points P and Q is the load resistor. You can mark it as RL. Now, if the coil is rotated, then there will be current induced in the coil, and by applying Fleming's right hand rule, I can conclude that current across AB will be moving up, and whereas current through CD will be going down from C to D, and finally that current will reach slip ring S2 and then via carbon brush B2 will reach the load resistor out here, and that same current will go through the carbon brush B1, then through slip ring S1 and reach point A to complete the circuit. Now when the coil completes half a revolution, then CD will come here and AB part of the coil will reach there, and in that case the current in the coil will be reversed. So just now the current is flowing from A to B to C to D. In that case the current is going to flow from D to C to B to A. So as a consequence the current direction will be reversed, and such a current which continuously reverses its direction after every half rotation of the coil is called alternating current. So basically an alternating current is induced in the coil due to this continuous rotation of the coil in the magnetic field. And as a consequence I can say that an alternating current is induced in the coil due to continuous rotation of coil in the magnetic field. And this current induced is due to change in the magnetic flux linked with the coil. The next question, 9 part C, calculate the electrical energy in kilowatt hours consumed in a month in a house using 2 bulbs of 100 watt each, 2 fans of 60 watt each. If the bulbs and the fans are used on an average of 10 hours each day, if the cost per unit is rupees 3.5 and if the cost per unit is rupees 3.5, then calculate the amount of electric bill that is to be paid per month. Now we'll assume, since the month's name is not mentioned, we'll assume the month to have 30 days. Now I'll make a table to simplify our calculations. So the first column is device. There are only 2 devices technically, the bulb and the fan. Then the second column is power, but we need power in kilowatts as we need to calculate energy in kilowatt hours. The third column is time, which should be obviously in hours again as we need to calculate energy in kilowatt hours. And finally the energy itself in kilowatt hours, which is technically the product of the second column and the third column. So basically energy, which is power into time. Now there are 2 devices, as I told you all, the fan and the fans and the bulbs. The fans are of 60 watt each, and therefore each of them are of 0.06 kilowatts into there are 2 fans. Similarly, the bulb's power is 100 watt each and there are 2 bulbs. So as a consequence, we can say that power of the bulbs is 0.1 kilowatt into 2. So basically the powers turn out to be 0.12 kilowatts or 0.2 kilowatts. Now each of them are used for 10 hours a day. So therefore in the whole month's time they'll be used for 10 into 30 hours, that is 300. And finally, the energy in kilowatt hours can be calculated using the formula power in kilowatts into time in hours. That is, we need to multiply the column number 2 with column number 3. So that will be 0.12 into 300, that is 36 kilowatt hours. And for the fans and for the bulbs, it will be 0.2 into 300, which is 60 kilowatt hours. So total energy consumed in kilowatt hours will be 36 plus 60 will be 36 plus 60 kilowatt hours, and that is equal to 96 kilowatt hours. In rupees will be number of kilowatt hours consumed into cost per kilowatt hour. So number of kilowatt hours consumed is 96 and cost per kilowatt hour is given in the question as 3.50 rupees, and as a consequence the answer turns out to be 336 rupees. So we can write 336.00 rupees.